Okay. Recording? No, that's not. So in this part, we are doing a little bit more advanced now object orientation, and it's called dependency injection. And I will first explain, I need 2-3 slides to explain what is that. Then I will switch in our code, which we have right now, and show how to do that. Take a look at these two pictures. First, on the left. The left, we have 3 classes, A, B, and C. So animal, bird, something, input processor, whatever. And in this case, when we compile, it can be that the class A is touching the class B, and class B is touching the class C. What does it mean? I switch shortly to our code and explain what does it mean as example. Here, for example, if I'm in a processor class, this is, for example, class A. I go to the processor class here inside of it, and inside of the class, that's the wrong one. I need this one. This one is dealing with animal and bird. And if I go to bird, the bird is dealing with animal. So dealing, touching, this is just slang. In real English, this is called dependency. Dependency means, in this case, class bird depends on class animal. Here, class processor, input processor depends on bird and animal. And the class program depends on input processor, on a printer, and input processor depends on class bird, animal, and bird from animal, and so on. And this dependency is called dependency graph. And I switch back now to the presentation. And in the presentation on the left, I have dependency graph during compile time. So now it's following. On the runtime, I have this dependency too. Nothing changed. Nothing changed. But sometimes this is problematic. If you want, for example, to test your software, just one example, and during testing your software, you want, for example, to exchange this class B against some test class B. You have no chance to do that because dependency between A and B, is building in the compiler. You have no chance to do that. But sometimes it is required to do this. One reason for this is testing, and we will learn about testing in 2 weeks or 3 weeks, a lot of testing, unit tests. So that means class B is not exchangeable, class C is not exchangeable, class E is not exchangeable, nothing is exchangeable. It's fixed as it is, and that's a problem. Sometimes you deliver your software to your customers, and once your customers make a choice, for example, you sell to customer A, B, and C, but you give a choice to customer to replace your B by somebody else B. Well, it's a good thing for customer. And in that case, you cannot do that because it's everything built into this dependence. And that's important. So to solve this problem, there is something what is called inverted dependency graph. And this inverted dependency graph is today called as a pattern inversion of control. That's very important. What does it mean? This means following. The class A depends on the class B, but it depends on the interface, which is called interface B. And the class B is just an implementation of this interface. you can have another implementation. Our example, in the previous example, what we have, you remember this input processor. We had input processor and then my input processor. And both these processors implemented a single interface. It was called I input processor. And this is, in this case, IB, implemented by B, B1, B2, B2, it depends on that. So, but important is here that A doesn't depend on B. It just depends on the contract. And the same thing, B doesn't depend on C, but it depends on interface with C. When you do this in the runtime, you will have actually the same thing. The class A will create a control call. This is called that way. It will instantiate class B by configuration, which is actually implementation of B, and C, which is implementation of C. And this is how it works. So basically, inversion of control means when you cut dependencies from things and build dependency to interfaces to abstract things which are interfaces. This is why we learned interfaces at the end of the previous lesson. Hope this is clear. So I think it should be clear. So you might not be now clear why is that really so important. And so we will step by step do this, and I will show it in a moment. Years for this. So this is the last theory step. Inversion of control is a pattern, and this is the pattern which replace dependencies to classes by using dependencies to interfaces. So far, so good. Now, inversion of control has two groups. The first one is dependency injection, and the second one is so-called service locator, which is more or less similar, not same thing, and many developers are today confused what they really want. It doesn't matter. I will show you what. And choose for you, it doesn't matter how the things are called. If you can use them properly, you are perfectly fine with that. So once again, the pattern in theory is called inversion of control. There are two of them, two approaches. One is called dependency injection. Another one is called service locator. What does it mean, dependency injection? Dependency injection means following. If you have a class, and inside of the class, this class is implemented in some framework. One framework in this context is ASP.NET. We are not going to cover it in this course, but it's just framework. And when you write in this framework something like this, you remember Blazor last time, this .NET Conf what we had, and so on. You can implement a field and put on the field something like inject. This is called attribute. This will be automatically instantiated when the class is instantiated by framework. This is called dependency injection and setup property. Dependency injection by constructor injection is a typical form like this one. When you create a constructor somewhere, and inside of the constructor say, I want to have this another class or something like that, and this thing is automatically created for you. So you understand now. Our application, previous application, I will show the demo, yeah, has this input processor, had this printer, and these two things. And if you are somewhere in the code and wants to have your printer, you will say new printer. You will say somewhere new input processor, new this, new this, new this, new this. But when you change the implementation of this and initialization and configuration, then you have 500 places where this happens. You understand that? So you want a simple change. For example, new animal, you remember, we had an animal name, kind, identified, and we had these legs and wings. And after a while, we say, hey, this is not good. Let's change our approach, introduce a class bird, which inherits from animal. And in that case, I had to go to all places where I had a new animal, remove this last parameter, which was wings, and go to bird and remove the parameter, which is called kind. The word bird is clear kind, yeah? And something like that. And if you have hundreds of such places, you need the days to change this. It's almost impossible. And for this reason, it's good to have a single place, which is called factory sometimes, yeah, which creates this stuff. And dependency injection like this helps doing it. In this case here, for example, this class, this class in some place, somewhere, I'll show where, registered, created, and when you need it, it just creates it for you. It just created. If you need this in 1,000 places, this, you just say, give me, you will get it. And there is a single place where it's created for you. So, service locator is similar, but it works a little bit different. Service locator typically has some class, which is called service locator, look at SVC lock. And you call this class and say, give me the service of interface for my class. And the things give you. And if you change how this my class is implemented, you don't need to change anything else anywhere because it's always the same. Service locator, give me this instance. Give me this instance. And this is good. It saves you time. Hopefully, so far, so clear. I know this is now kind of clear, which is fine. Now, let's show the example and hopefully it will be clear. And I promise you, for most of you, will not be clear, but you will just need the time. This is about object-oriented programming. At the beginning, feels very easy, and everybody say, yes, yes, that's clear. And 5 years after, they say, oh my God, 5 years ago, it was not clear, which is fine. Okay, but you will not have any problem with it. What I'm going now to do, I'm switching back to my example, and I want to use dependency injection. To use dependency injection, I need 2 libraries. These are packages. I maintain these packages in our last lessons, and we will, I think, next time learn much more about this. And just now for this, we just do the following. I'm going in like sample here, go to and go get package and say, please give me this package. Now it's going to the repository of these packages, looking up for this and saying, where is it? Microsoft extensions.hosting. Okay, let's take this one. Add it as hosting, and another way to do that is just to come here and go to your project file, and you could actually copy this line of code inside of this. So that means I would copy this. If you know which package is that, it's the same as coming here and say manage a package. Please be aware of that. We will do it hundreds of times in your project. So sometimes we will use these package manager options, and sometimes we will go directly in the project file. Depends. If you don't know the version, you go here right way. If you just know the version, I want to have that one, then go to this project file, just upload it, paste it there, and that will work. So once I do that, I pasted some code here. I will explain it now in a moment. I just need the namespaces, control dot, it up this, and give me that. So I have 2 new namespaces, dependency injection and Microsoft extension hosting. So I'm pasting this code now, and instead of these 2 lines, yeah, I will come to that too. I will need to change them. There is following. There is something is called host. This is dependency injection host, and these say, hey, create default builder, configure services, blah blah. Just copy paste this code. Okay, don't think so much about it. It's a small framework. It is not that quick. And say build. And this build gives you the back host, and host has something which is called services. And services is this from PowerPoint presentation, this factory, this service locator. We say, hey, services, create the instance of this class. Give me the instance of this class. Before this came forth, I have this input processor, look at this. And this input processor, I will copy this. Processor say, please instantiate singleton. We'll explain what's that. The instance of this interface by this implementation. Why is this important? This is important when somebody later comes here and say host services dot service, and you say, hey, give me the service of this. I'll give you here something, and this something, look at here. What is that? This for type. This is in this case of this type, because I say, I will for this interface register this type. And when somebody asks me for interface, I input processor, I will always give this type. This is the single place, single line of code in your application where you define what is this interface. Once you change this, want to change this, independent how big is your program, it's a single place where to do it. A single place. So let's try to do this. Thing is, let's implement this animal printer. So to do animal printer, where is that simple animal print? I will come here, say right mouse click, and I will extract the interface to this one. This is what we did in last lesson. And I will say animal printer. Okay, and everything is fine. Let's do now simple animal printer and implement another one. And let's say here, color animal printer. Color animal printer. I'm just changing the code, same way, it's everything more or less same. And I will here console color equal, let's say green. Yeah, this is the only change of the print. So now we come to program. And we use simple animal printer first thing, okay? So this is the initialization of my code. That means this part of code needs to be created, to executed, to set up all this. Are you still with me? I have a feeling some of you I'm losing a little bit, but it's about dependency injection. That was expected. Okay, once again, I come here now. Here's my code from last lesson. And in this code, I say my best input processor, simple animal printer, and so on. I'm not going to do that now. I'll come here and say register services, and here is my service locator. And service locator is actually this thing. So why I need service? Service locator is used to create an instance of something by inversion of control. So I will come here now and not say this. I will say service locator, get service. This one. I input processor.
Could you please explain the injection process again on the green board?
Sorry, can I play what?
The injection process on the green board.
Of what? Of
The injection process that you were explaining about registering. Can you explain that on the green board?
on the green board. So this is for everybody here on the audience. They want to explain this on the green table, but let me do this here in the power. Okay, because they don't see what's going on here. Notepad, first of all. So what's going on? If you have some interface or some class, let's say this is the class A, and I have another slightly different implementation of A, like let's say this is A1 and this is H2, A2, and this both if I'm not sure which one I should use. That's one thing. Another reason is I want to provide testing for this class. Sometimes I have no A1 finished, but I need some testing client for a class like A2. Or I have a fake class. This is sometimes called mock class. Once again, we will learn about this in 2 weeks, about testing. But for you, it's important right now, you don't have implementation of the class. You are not sure how it will be. You just know the contract. You have to agree on. If you don't know contract, you know nothing. Yeah, actually, you cannot write code. Yeah, anyway. So our contract is in this place, interface, let's say, interface A. So now you can, for example, if the implementation of A takes 6 months, A1, A2, doesn't matter, 6 months, 1 7, 1 year, yeah, and you have no time, your job is to implement the application with any implementation of this contract. You're implementing here your code on the left side, and you cannot wait 6 months on the people. So you will implement a fake of this class. And to implement a fake can be just through exception, console right line on every method and every property and so on. In that case, you can make that. But how to exchange all this 6 months later? So one of good practices to do that is the inversion of control. Inversion of control means deal with interfaces and not with classes. And once you do that, you use an approach which is called dependency injection or service locator. It's both very similar. Don't be confused with that. Okay? Dependency injection is when your code is automatically initialized, and service locator is when you call service locator and say, hey, give me the instance, as I did in the previous example. So that means you will somewhere here, you are in code here. This is your code somewhere anywhere in the code, and you have a constructor of your code. And in this constructor, you need A. But you know you have no A now. But you know you have interface of A. Then you say, I want to have interface of A and put it in variable I. Close. And here's implementation of the constructor. Dependency injection makes sure that this interface of A is injected in the constructor for you. You don't need to do it. This is why it's called injection. When dependency is because it's inversion of control as a theory slide number 1. It means you have no direct dependency to the class, you have dependency to the interface. Okay? So this is dependency injection. Service locator is also inversion of control. So this is one possibility. The second possibility is when you have a service locator, this is also class. That's one what I show right now. And you say of this class, hey, give me this thing, get. And you say what? And in this case would be, you just say give me. And you get it. Push it. I will take a screenshot of this now and put in a PowerPoint presentation. It doesn't look that beautiful, but people say one picture, more than 1,000 words. So I'm coming back now to my code here and try to explain this picture again. Look, if I want to have this, the service locator, give me this thing. It's not saying what it is on this line of code. You just get it, and it works. Also here, I don't want to have this simple animal printer. I will say, I just copy this, and I want to have this thing. Get service input processor, and this thing will not be that. It will be my animal printer. Okay. And here say, this can be null reference exception or something. Yeah, I don't care. Don't care. You should not do that in the real life. Yeah? So what's here? Here, I said this guy. So, just a moment. This is the code what we had. I did a copy for you. This was before our lesson. Last lesson, they say, new my best input processor, new simple animal printer. I have dependency on this line of code, yeah? I have dependency to this thing. In this way, I have no dependency to this, in this line of code. I have no dependency. I just say, hey, give me this interface. But how this thing knows what should give me? It knows in this registration, where I say, wherever somebody asks you for this interface, you will do this thing. Okay, and after 6 months, when the people have implemented this real one, not a fake, I will change only this line of code and say, real, not a fake. And I'm not touching anything else in the code. Okay?
Okay.
Yeah, please.
But let's suppose input processor needs to give you with certain results, and while we are running our code, so what result currently the input processor will give at this point in time?
What result it will processor give? I'm not quite sure I understand your question. So processor will give result it is here. It's defined by contract. Your fake implementation will not give the list of all animals which user had entered. It will give you maybe 2 animals, just that you can work. Okay, for example, let's come. Here's my best input processor. So let's call this thing is not my best, it is fake. In fake input processor, there is an engineering word for faking. It's called mock. Mock input processor. And this mock input processor will come here and give empty list. But maybe I will not have an empty list. I will do following list. As I just do it this way, yeah. New animal. The animal will be 1. Name is there's guy dog. Place 4. So it's 5 and 1. Yeah? So and at the end. So that means you cannot wait for somebody to implement this processor, this one, it's a lot of code and so on, but you can take this mock input processor. And here's what animals, what is this? And what should you do here? You will come to the program and say on the place, when somebody asks you for an input processor, you will give this mock thing. Yeah. This is the only place where you change this. There is no another one. This is cool. This is really cool. So another thing what I have to change here, because I have no here. I have animals here. I will come to input, not input, it's printer, where's printer? Animal printer. I will put here list, animal. Then I will come to this guy will automatically fail. I don't need this. I'm just simplifying a little bit, okay? This, and I will put that in the list. Animals. So I'm not showing anything new now. I'm just playing the previous example from previous session. So let me see if I can compile. What's happened here? Oh, sorry. I said a minute ago, don't play with this file, yeah? It can happen, that thing. So it fails. Print, and I have to put these animals here because I changed it now. Contract of signature method. Yeah. So what you see now doesn't implement. Why? So this one also need print animals. Yes. This. I'm providing animals here. Now it should hopefully compile everything. Field favorite. One. We don't need that. Yes. This is last thing, which I just wanted to do, that we can compare new one and the last one. So what is the difference? Once again, I say what I need. I say what I need here explicitly. And here I don't say what I need, I say by interface. I need this interface, and I need this interface. And what will be done when I say this interface is defined here. Now there is something which is called singleton. I didn't explain this. A singleton is the instance of the class which exists in URL code only once. There is a guarantee that this class exists only once in your code. Okay, this is called singleton. So this is what I'm using here. I only need one single input processor and single printer. So far, so clear till now. Before I run this.
Yes.
I'm not so sure. I'm not so sure. So what I'm trying to do now, yeah, I'm putting the interfaces contracts around classes, but not around all classes, around animal and bird. I didn't do that. So in theory of this, I maybe should do that, but in the practical life, in real life, I'm not going to do that. These are so-called entity classes. The classes which does some job, like input processing and so on, heavy stuff, you should do that. And this is what I did. I did that for two of them, for input processing and for output processing, which is printer. So let's come here now and see what happened here when I start the application. I put the first breakpoint, hit F5. I go step into the function with F11, and in F11, I'm registering that. So this is what happens. Just wait for a second, and it's done. So this line of code was testing line, which I was explaining. We don't need it, but let me see. When I call on host, which is this one, dependency injection host, I say, give me the service of input processor. It will give me this one. And what is this? OOP, mock input processor. Why it's mock? Somebody asked for this, you will give this. I asked for this, yeah, this is this, and I'm getting this here. Again, s dot get type. Something which is really useful. So what is this? We say, okay, mock input processor. So what is doing the mock input processor in our implementation? How to know what is that? Control, comma, mock input, and look at here. Here is this window. When you say control, comma, it looks you, it is like Google search, but by type. It just gives you type name, not something. Yeah, but it's font something. Yeah? It's just type. And you click on that one, mock input processor is give you two feedback. Yeah? It will not ask user to do anything. So let me do that. We come back. And now, give me input processor, and input processor will be what? Mock input processor. Process. F11, I'm stepping in so, and look, it's coming here and giving you two previews, and that's it. And now, get service, animal printer, and print animals. So animal printers here, two animals are printed. So now, a few months after that, you second team comes and say, hey, we have finally implemented the call of printer. What are you going to do? Okay, you have implemented. Where is implemented you call of printer? The call of printer is implemented in call of animal printer. This is the place where you are changing what will be done. You come here, okay? What? Animal printer. Whenever somebody asks for animal printer, now you give real animal printer. Okay, let's start the application. Block input. How many animals? 2. Give me the printer. What is the printer now? Color animal printer. Print. I see it's printed with colors. Okay. Now, 3 months after that, your team, which is implementing input processor, coming back and say, hey, finally we are done. You say, okay, that's that. No more work. I will use input process. That's all what I do. I need for that 10 seconds time. And I start the application. F5. Please enter the name of animal. The kind is bird. Enter the name of what's the next? The next one, yes. The name, it's a cat. Has 4 legs. Exit. In call. The application is done completely with fully dependency injection and so on. I'm thinking, huh? I'll just give you a few seconds to think about it. Any question in the audience? No? Good. Okay, that means everything easy. I show you something complicated. Okay. Now, let's think about the following. I have in my, so I'm thinking some of our scenario. I don't know, I need some idea of some other class. With some class. New class. Sorry, let's say, sorry?
Weight of the
Weight of?
weight of the
Weight of, it would be too much simple. But let's go follow. Logout. Logout. Or my tracer, and I will not confuse you because we will learn about my trace. So what this tracer is doing, you want that somebody, that you protocol your application, every step in the application, you write in some log file or something like that. It's called log trace. That's very important. So, and now to do this, we'll have a public here, and you have a method, public, void, trace, and in a trace, I have string message. And here I will write is right line message. What's in it?
What are we doing with the?
I will explain just one minute. So I will explain you what this thing is doing. To start up to convert everything. Here starting our application. I say my tracer, my tracer, okay? And when I come here and say tracer, trace, and hello best students. Okay, and this thing will write something. What's this? Tracer hello best students. Now I will put this breakpoint here. I run that. What's happened now? Look at here in this window. I will clean that everything. When I say trace, I go into that one and say debug right line. It writes here. Huh? This is what it's doing. It writes you here in so-called trace output. So this can be good if you don't want to put the breakpoint in your application. You just want to see where the code was running. Okay? Very simple. It's just one line of code. Are you still with me? This is not so complicated. Tracer.
Basically, we get confused about what is the flow of the program. To find that.
Correct. If you want to figure out what is the flow of the program, you can use something like this. So this is not something what I want now to do in this application. I just want to show you a little bit more dependency injection, and I ask you to give me some example class, and I found out maybe this is interesting. Let's do that. Okay. And it's interesting not because it's dependency injection only, because you will need it in your project. You will need it. So let's go there. Let's go and trace now. So I can write here now and say tracer. Hello, sleepy students. I have created a list of animals. And I can also come here and say, finally, but not yet. So, and what this will do, I don't want now to type all these names when I start the application. So it is very good because I'm testing. I will come here and say input processor, I will call it. So I don't want every time when I start now to 50, so on and so on and so on, and type a day. So I just change this to a single line of code to dependency injection. Yeah. And I run this and put the breakpoint at the end. Yeah. I just want to show you what is written in the debug direction. So, hello, sleepy students. Finally done. And look at these guys here. Yeah? This here. It's in the meantime written, and here's my one. It's written by .NET Framework. This means Microsoft also and anybody else using the trace to see what's going on. This is only debug version. When you compile, release it, and get to customers, there is no difference. Okay? Yeah. Why is this now important? Now, I don't know where I'm going to trace. Right now, while I'm debugging, it's for me pretty good to trace in a Visual Studio debugger. But when I go to the production, maybe I want to change this to trace to the file. How to implement that now? So before I can implement this, I need a concept, I need a control. Like this, here's my tracer. Right mouse click, I'm extracting the interface to this, and say extract the interface. And interface will be I trace that. And I have a single method get. So to make this everything happen, it should be. I will come here and say this will not be my tracer, it will be typed. That's how everything will work. Huh? I just change the interface. Okay. Look at it, finally done, I'm sleepy, finish. Okay. Because I want to use dependency injection, I will not use this way. I need a service locator. And still. So tracer. I will copy this. tracer. That. So this is my tracer. I have created the tracer and I can trace now. You believe me that this works? I don't. I never tried. Oh. Okay. Why does it work? Because this thing doesn't know what is eye tracer, and to make it happen, I need something like this. And here is also in my case. Yeah? So, because this is debug. Okay, so let's make some my debug window tracer. So now it's everything fine. Nothing changed. I just changed the name of the class. F5, I'm starting. Everything works, look at it. Everything works, my application works. My application is right in here, this is my application here, and the tracer is right in here. Okay, so now, I want that tracer is used not only here, it's also used in all my components. How to do that now? So now I'm not using, because I have initialized everything by service locator and so on, I can use now dependency injection. And if I come to my, for example, mock input processor, I can write in mock input processor something like this. Hopefully this will work now. I tracer. I what? Build. I tracer. The naming, real naming convention, currently actual naming convention by Microsoft, it is one with underscore. Huh? Tracer. Tracer. Control KD make format. For example, if you have formatting something like this, yeah, Control KD will format everything that you have. If you select all code and say Control KD to format all code as it should be. Okay. I have a tracer and come here and say tracer, trace, and started processing animals. So look at them.
Do we need this dot tracer there?
Do we need?
We say this dot tracer.
So the question is, do we need to use trace? Thank you for asking this, because in the last lesson I have been using this dot, this dot, this dot, this dot. You don't need to do that. This is agreement in a team. It's naming convention, code styling convention. Actually, I use this dot to give you a feeling that what we are learning in our object-oriented programming with this means I'm accessing the property which is the member of my class. If I don't write this, it is a member of my class or my method where I'm playing. So I can use this without. Doesn't. I would suggest to you at the beginning to use this to learn explicitly that you use member of the class. So here's an interesting follow. Who is making this instant? So mock input processor is created here. So this one doesn't work now. Look, this is all code from last lesson. Huh? It doesn't compile now because mock input processor expecting the tracer now. But what I could do, I can do following. If this can be or doesn't have to be, I can say it can be now. And this one can be then nullable. And this one must be nullable. So I will put the breakpoint now and start the application. And there is a tracer. And if you take a look now on the calls, take who is calling when, and there is here something in the right mouse click and say show external code, and you will see that here's dependency injection framework. When I call the method register services, I double click here when I'm here, and I'm asking here, this was this demo code, yeah? I don't need that code. Give me the instance of input processor. An input processor will come here by dependency injection and say, hey, what is registered for input processor? It's mock input processor. Hey, give me the instance of mock input processor. And to create instance of mock input processor, that can say, hey, the mock input processor needs tracer. And that this dependency injection framework looking for an instance of the tracer, making it and put it here inside. Okay? Good. So what you can do, actually, you don't need to use dependency injection, yeah, in a small program. You don't need. I'm not forcing you to do that. But my job is to explain you that this thing exists and it's a consistent part of a modern programming framework. And this thing is powerful, kind of sometimes quite complicated, but it's really not. So you can do like this. You can come here and say, hey, this is my print. It was my input processor. Look, it can have a tracer here, which is not. But I can also put the tracer here and say, new, my, what's called my Windows tracer. I can create this thing, and it will also work without dependency injection. It will work. There is no any problem with that. The problem is only when your program is a big, and you have many such places. Give me a tracer. In every component to use a tracer, you have to say new tracer, new tracer, new tracer, new tracer, hundreds times, yeah? And now let's make another tracer, and then you go back to the code. Let's do that now. You make another tracer. New class. And I told this my public. Which interface do we need? Trace. To implement the interface, control dot, implement the interface. And what this thing is doing, robots, ring, file name equal tracer.txt. So actually, I didn't want to do that, but was a question, yeah. String writer equal. We had a practice exercise writing to files. I hope some of you are done with this. Append is true, so that means I want to append to this file. So I'm writing to the file. Okay. Now, to replace that, what to do now? I always go to the single place code, and tracer will be exchanged with my file trace. The application is done. So now, where is my application? You can tell me that. Bin folder, but somewhere here's the application. Here's my trace file. And it was writing here. Hello, the student started processing animals. Hello, sleepy student. I have created list of animals. Finally.
Won't we get the animals printed in the console?
Sorry, I didn't hear where we get.
The animals printed in the console, the output, actual output of our program into the tracer file. Can't get that.
How do you mean we can't get that?
In the text file, we just have the text we have entered in the
Yes.
given code.
Yeah.
So we have the output also from the console.
Yes.
How can we get that later? Can we get that to a text file?
So
instead?
you mean this output of the console to get affected? Where was this output? Where's my console? I don't have it right now, but let's start it. You mean
Yeah.
this console with these, we will write these console write lines.
Whatever we print.
So just a moment. So this should be my, you mean this? So if you want to write that to the, so the question is following now. We have output of the console in this printer, yeah, here on this screen. And now there is a customer and comes with a great feature and say, hey, this is cool, but I want to have this in a file. So this is great practice now. It's a nice question. How would you do that? Look at it. First of all, you ask yourself, now it's writing here. Where is the place of writing with this? So let's go, I stop this, and I go in the code, and place to write that is in my animal printer. An animal printer is simple animal printer and color animal printer. I have two of them. Yeah, for example. And this is the place how I write it. So if I want now to have a printer which is writing to file, I could implement a new printer by this interface. For example, it cannot be color file printer, it can be just file printer, and it would write this not here, it would write in a file. If you like, we can do that. So, where's my file? Is here. File animal printer. File animal printer. And here we don't need this. We will have using writer, string writer equals new string writer. I need some file name. In this case, I will say animal log.txt. Then I have this, and instead of this, I will have that. String writer and string writer. So this guy is called file animal printer. If I want to exchange all functionality of writing to console output to the file, there is a one place as this one. Let me see if that works. So I implement a lot of code here, and you need to pay now for this. Yeah? So this is done, and I go here in how it's called. Here, animal log. So let me see. Thank you for asking this question. This was a really nice example to show how you can, in just a few minutes, exchange completely functionality of the application. We could send SMS now, post a message on WhatsApp. It would take a little bit longer, but you wouldn't change the code. It's dependency injection. So I hope This is fine to you now. We make 15 minutes break now, and the last session is about configuration. 15 minutes. So this is now 5:20.